Hi there, welcome back to the Python Mastery Crash Course. I'm Gority Golden and I'm super excited to help you master Python programming. In this video, we are going to explore the world of Python modules. So let's get started. Modules are pre-written code libraries that provide additional functionality to Python programs. So they are more like building blocks that we can use to construct our own projects in Python. Therefore, a module can be referred to as a file containing a set of functions, variables, classes, etc. that you can include within your application. So modules help us to organize our code and also make it reusable. For example, if you define a function within some file and reuse the function in some other files. In addition to that, the modules also avoid duplication, meaning that they enforce the dry concept of do not repeat yourself. And lastly, the modules also provide a way to share code with others and to use the code written by others in our own project. Now, Python comes with a vast collection of built-in modules that we can use in our programs. So these modules always provide functions for various tasks like mathematical operations, and sometimes you can also work with file input or output operations, and on the other hand, network communication. Let's look at the mathematical operations. For example, we can use the math module to perform mathematical operations such as calculating the square of a number. Before calculating the square root of a number, the first thing that you have to do is importing the module. And in order to work with the module, you always have to first import it by working with the import statement, and then you follow it up with the name of the module. So for you to be able to carry out calculation of the square root of a number, you can work with the math module. So you import the math module. And for example, if you wanted to find out the square root of a number like 16, that means that we can go ahead and create a variable called number. And we can assign this variable a value of 16. And in addition, you can also go ahead and create a variable to score the square root result. And then we are going to assign this by first of all accessing the math module. So for any module, you can always access the variables, the functions, and etc. that are in line or related with the module, or that can be used with the module by working with the dot operator or the period or the full stop as commonly known. So you go ahead and access the full stop, and it's going to list a number of methods like functions, constants, and etc. that can be used with this module. So in this one, we are interested in the square root, so you can go ahead and type square root, and you see that when you hover, before you even add the parentheses, it shows you that, hey, this is a function, and you must now go ahead and ensure that you are returning this as a function. So it shows that it returns the square root of x, and in this context, x is the number that you want to work with. So therefore, you have to go ahead and assign it or provide the parentheses. So all you have to do is to pass in our variable, which is number. And having created that, the fact that you want to go ahead and also have an output for this problem, that means that you can still work with a simple output by working with the print function and going ahead and, for example, providing it with a string literal like the square root of, so the square root of, then we can just go ahead and add a comma here, then we can pass in the number, and then is, then you can now go ahead and pass in the result, and the result is stored in the square root variable. So having created this, we can go ahead and execute this program to ensure that we do have an output. So precisely, you can access the file, and you can see that the file is modules.python. So you follow the command with the file name, and now you can see that the square root of 16 is 4. In our previous video, we worked with functions, and we also worked with the math module in that we were trying to access the pi constant. So when you look at this, this is part of mathematical modules in that we are trying to access constants like the pi constant. So the import statement must only be imported once. So with the pi constant, you can see that we can also access it from the math module. And maybe to make this expression better, you can also go ahead and pass in some parentheses. And when you try to run the program, you can see that we are having this kind of output. So you can define a local variable like pi value, and then you can work with the math module, and then you go ahead and access the pi constant, than having the value created by yourself. So within this function, you can also have a look at the pi value from this constant. So you can see that the original value of pi is 3.14 plus these other. Next up is the random module, and this is always used to generate random numbers, choices, and also to shuffle lists. So for example, you can use the random module to generate a random integer between two numbers. So for any new module, the first thing that you have to do is to import the module, and therefore we are going to ensure that all the modules are imported at the top of the program such that our code is organized. So we are going to have a simple comment as importing all modules, and we are going to ensure that the math module is imported and the random module as well. So the one thing that you have to keep in mind is that you cannot make use of a module before you import it. So if I go ahead and I comment those two import statements, you can see that math is now not defined. So therefore you have to always ensure that you import the modules before using them. So having imported all those modules, we are now going to go ahead and work on our example. So the first thing that we are going to do is creating a variable that is going to store the value for the random number. So we can have the variable as random number, and we are going to get its value by working with the random module. So the first thing you have to do is accessing the random module, and then you go ahead and work with the full stop or the period accessor. Then having done that, we do have the rand in it, and when you try to hover on it, you can see that it is also a function that returns a random integer in the range of a and b, meaning that the ranges are always user defined, including both endpoints. So that means that you have to go ahead and pass in the parentheses to ensure that it is a function, and you can also see that it always has a return type of int. So the range, we are going to work with 1 to 10. So having defined that, we can also go ahead and create a simple print statement that is going to have a string literal as the random number is. Then we can go ahead and pass in the random number, and of course if we are working with the curly braces, then this has to be an f string. So we pass in the random number, and we can now go ahead and test the program. So the output is the random number is 8. So just like the way the module sounds, random meaning that it is always going to return a random number whenever we work with the program. So according to our approach, when I try to run the program once again, you can see that this time we are having 9 as the random number. And if I try again this time round, the random number becomes 7, and this other time it is 3. Meaning that whenever you run a program, it is always going to give you a new output than the recent one. So realistically, the random module is useful when you need to generate random data for testing, or sometimes if you want to work with the simulation processes. Now let's talk about the statistics module. This module is always used to calculate statistical measures like the mean, the median, the mode, and also the standard deviation. For example, if you wanted to calculate the mean of a list of numbers, let's say that we do have a list of numbers, meaning that we have a variable that is storing numbers in a list, and precisely we can have numbers from 1 to 5. So to be able to calculate the mean of these numbers in the list, the first thing that you can do is creating, for example, a new variable that is going to store the result. So this can be created as mean, and then make use of the statistics module. So since it is also a new module, the first thing that we have to do is ensuring that it is also imported. So you can have import statistics, or instead of having all these import statements on different lines, you can also have all these modules imported on the same line. So we can import math. Then initially we had the random module. So you just go ahead and add a comma for multiple module imports. Then we also now need the statistics module, such that your code is very organized and efficient. So having updated that, we are now going to ensure that we access the statistics module. And just like other modules, to access any functions or constants, you have to work with a period operator. And then in this one, we want to go ahead and work with the mean. That means that you have to access the mean. And when you try to hover, you can see that it is a function and it takes in an iterable. And this is an example of the mean. And then you can go ahead and pass in an iterable like a list. So in this one, that means that it is a function. So you have to go ahead and pass in the parentheses. And then it requires a parameter for the data. So in terms of the data variable, all you have to do is passing in our defined numbers list, which is the iterable. And having done that, just like we did for this other random module, you can just make use of this print statement and have it reused here. And then instead of the random number is, we can have this updated to the mean of the numbers is this much. And this is now going to be substituted with the mean. So having done that, we can now go ahead and also test this out. So we are having the mean of the number. So you can ensure that this is in plural format such that it makes more sense. So the mean of the numbers is 3. So you can see that the statistics module provides a convenient way to calculate statistical measures in your Python programs. Next, we have the Datetime module, and this module provides classes for manipulating dates and time. So for example, we can use this module to find the current time and date. So the first thing that you have to do is ensuring that the Datetime module is imported. So within our import statement, you're going to also ensure that the Datetime module is imported. And having imported it, we can now go ahead and create a variable that is going to store the current date and time. So I'll have a variable called current date time, and to access the current date and time, the first thing that you do, just like we have been working with other modules, you access the module. And when you access the module, you can see that we do have the date time. So you go ahead and access the date time, and then to access the current time and date, you go ahead and access the now function. So having done that, we can still make use of this other print statement and go ahead and update it to the current date and time by saying that the current date and time is, then we can just pass this in precisely. So having done that, you can also go ahead and test the program, and you can see that the current date and time is this. So generally the Datetime module is always useful when you need to work with the dates and the times in your Python programs. So you can go ahead and explore more functions that you can work with and formatting of the dates furthermore in terms of the Datetime module. Now let's talk about the operating system module or the OS module. So this module provides functions for interacting with the operating system. For example, you can work with this module to list the files in a directory, and since it is a new module, the first thing that we have to do is importing the module. So we can have this imported as well from the OS module, import OS. So import OS or import the operating system module, and having imported the operating system module, we can use it to list the files in a directory. So that means that we can have a variable called files, and to access the list of the files in the directory, the first thing that you have to do is accessing the module, and then we can access the different methods on this module. So a method that you can use to list, for example, the files in the directory is the list dir, and dir in this context stands for the directory. So you can have list dir, and when you hover, you can see that it's also a function. So we can just go ahead and pass in the parentheses, and having done that, we can print the files precisely by accessing our variable and running the program. So you see that the output is listing the files that are in the directory that I am currently working with. And we do have control flow statements.python, dictionaries.python, exam.python, functions.python, lists, and etc., just like the way they are defined here. So you can see that the list directory function from the operating system module, it returns a list of the files that are stored within the current directory. And to confirm this, if I try to open up my Explorer, you can see that these are the files, and it goes ahead and lists the names or the file names for each file, just like they are created here, or just like they have been created here. So the operating system module, actually all these modules always have a number of functions that you can go ahead and explore with, because if we try to remove this current function and then you reaccess this, you can see that we do have a number of functions that you can use. So depending on your current goal or the task that you want to achieve, you can go ahead and work with any function. Now when you look at, for example, this one, get cwd, which stands for the current working directory. So when you try to hover, you can see that it is also a function. So what we can do for now, we can have this, I think we can have this kept in this format, and then we can just have the current working directory, for example, as a variable, such that we can print the current working directory by accessing this get cwd, which is get current working directory, and go ahead and pass in the parentheses. So when you try to hover, it's showing you that it returns a string, and the list directory returns a list type, just like we saw. So whenever a function is new to you, you always have the ability of hovering so that you get new insights on what the function is going to do, or what the function requires, or sometimes even what the function returns, just like you can see this. So this one shows that it is returning a string, and there are no parameters that are expected, just like you can see here. So get the current working directory, and we can now go ahead and have this printed as well. And having done that, we can now retest once again. And yeah, here we go. So when you look at the output, it's just listing the path of the current working directory, which is true because according to this, you can see that the path is this, and this only applies for the Windows operating system in terms of the backslashes for the path. But in case you're working with other operating systems, it might be a little different. But the main thing is that this is the path, because this is the main folder, as you can see. So there are a number of functions that you can always test out depending on your needs, and therefore you can go ahead and try to explore them. Now, in terms of the modules, we also have the user-defined modules, and these are the modules that you yourself can always create in a way that they can contain your own functions, classes, and variables that you can reuse in your programs. For example, we can create a module called mymath.python that contains your own mathematical functions, such as a function to calculate the area of a circle. So since we have already looked at how to calculate the area of a circle, what you can do is copying this code snippet here and pasting it within this file, which is mymath, which is going to act as your user-defined module. And having pasted it here, the first thing that you have to do at the top of the program is importing the module for math. So you go ahead and import the math module. And having created this with the module, you do not have to call this function from here, but you only have to use this module elsewhere. So for example, let's create a main.python file such that this is the file that we are going to use to have the output. So since this file is a module which is user defined, if you really want to look at the output, the first thing that you have to do is also importing the module. And just like we have worked with the built-in modules, you have to go ahead and import it using the import statement and then the name of the module. So the name of the module at this point of time is the file name of this file. So the file name is mymath. So you go ahead and say import mymath. And yeah, having imported it, we can now go ahead and call our function. So within this module, we do have a function called area of a circle. So that means that we can have this called by one accessing the module, and then when you look at the module, it has area of a circle. So you go ahead and call this function. Let's first of all try to look at main.py. And yes, we do need, when you try to hover, we do need a radius. And back to the module, we can pass in a radius as 5. And having updated that, we can try to run the program. And you can see that the area of a circle with radius 5 is this much. And still, if it is a user-defined module, you can work with a number of variables or classes. So for example, if you have a variable storing the age, you can also import it. So you can print the age by accessing the mymath module and then dot. You can see that we do have a variable called age. And if we retest this out as well, you can see that the age is still accessed. So when we import a module, we can also assign an alias to it. And an alias is a shorter name that we can use to refer to the module. For example, in our output file, where we are making use of our user-defined module, mymath, instead of having import mymath, like the original name of the module, we can have this updated by use of an alias. So the way you work with an alias is by working with the as keyword, and you go ahead and pass in your user-defined alias or the short name for the module. So in this one, you can just have this as m. So you always have to ensure that the name of the alias is shorter than the original name of the module. So you see that when you update or when you use an alias, the original name of the module is not going to be defined. So that means that whenever you work with an alias, you have to stick to the name of the alias. So instead of mymath, this is going to be updated to the new name for the module or to the alias name. So this is going to be updated to m and same applies to this part, such that if you go ahead and rerun the program, you can see that we are still having the output as what we initially had. So that's it for this video on Python modules. We have covered why we need the modules, and we also looked at the built-in modules, and same applies to how you can create your user-defined modules. And lastly, we also looked at the aliases. Remember that modules are a powerful tool in Python that can help you to organize your code and make it reusable, and also to avoid duplications. Thanks for watching, and see you again in the next video.